Hello everyone, welcome to my channel. My name is Sunil and today we'll discuss the design of localization service. For more such videos, please like, subscribe my channel. Now, why localization is important? Before that, we need to understand also what is localization. So, to show relevant information to the customer in the language that customer is comfortable. That is the purpose or that is the motto of localization. Let's say, let's consider about any user and that user is, let's say, French user, and the person's expectation is to see the product items or products listings in French. But if we show the products in English, then it will not attract the customer like it will attract in his or her native language. So by incorporating a localization strategy, you can reach people from different geographical regions. Whether you are targeting foreign markets or shipping across the country, it has been found out that customers spend time on a website that has the product information in their native language. Another use case, let's say you are trying to pay someone using UPI, and when you launch any app, if the content is in English, then it might not attract the people of any natives or people who are more comfortable in some native language rather than English. That means we are saying that by keeping in only one language, we are restricting or demotivating our customers. To increase that user engagement, this localization will be helpful. And these are basic use case of localizations, where a welcome note in any app or website that is in the user's native language, currency for every country flag and color scheme associated with the shopper's culture, and delivery options and tax informations. These are some we can say widely used place where the localization will be helpful. Let's take a look. Let's say we have built a page where user needs to enter first name, last name, phone number, where user needs to register or cancel. In that case, let's say we are targeting for some native states or from or some states in India. We'll find in village people may not know English much, but they are more comfortable in their native language. And as a business, our target is to get those audience or get those customers onboarded. In those cases, if we can change this text into their native language, then it will be impactful for them, or we can say another good achievement as a product, because we are encouraging the customer, and obviously the customer will be less motivated to leave. And in the previous screen, like we have entered those details, so there are various ways to set those things. And let's say our application is small or very small application. In that case, generally people or the colleagues enter or set those text as hard-coded text inside any file. We can say executable file. Like here you can see all those things are set in preface activity. And similarly, another example, let's in most cases we show some dialogue. There here we have entered those things as hard-coded text, and we have used set text. In that case also we can say we are showing some text in English. But let's say I have several screens. In my application there can be 50 or hundreds of screens. If we keep on writing the hard-coded text like that, then you will find those hard-coded texts are in all those 50 places. It's scattered. So what is the problem? Ideally there is no problem as of now, but as we grow we found that few texts are duplicate, or we can say same hard-coded text is mentioned in multiple files. So maintenance is a really concern. Like let's say we want to change some text, means wherever there was, let's say, confirm button, we want to change to OK, confirm text to OK text. In that case you need to make change in all those files where the hard-coded text is included. That is really painful. How we can avoid that? So solution will be all these displayable text. So what is the displayable text? The display text here we mean that the text which user can see it. So all the text or strings which user can see, those things needs to be put in separate file. We can say it will be in a particular file or files. So those and from other places of your code you need to only use the reference. You can use the reference and show the static test. Like profile screen can call to the, let's say, local.java file or string.xml file or any static content and use the text. And in that case we can find that lots of duplicate things can be avoided, and making change in one file can change in all the files. So in that case we can avoid the first problem that we faced of changing any text. Now we found there is another problem area, that as of now we are supporting English. Let's say we need to support French, we need to support Hindi. In that case what we need to do? We have already created one file. That means now we need another abstraction layer where we will say that we can create multiple files with the similar name, but the key of the text needs to be, or the name of the text needs to be same, only the value should change. Let's say something like this. Yeah, where we'll say, let's say first one is our French text and the second one is English text, where the string name is same, only the content is changed. And we need our wrapper class or our abstraction layer will take care of navigating, or we can say getting content from respective file. Then from code it will be like calling to our abstraction layer, and abstraction layer will internally check which data needs to be returned, and it will load the contents from that file only. In that case no need of changing in multiple places. And as also the key name, here the key name should be same of any string of any text. The name or the key should be same. The value only can change, Otherwise it will be very difficult, because we need to make change in lots of places. If the name changes, then the reference point or the calling environment, there also we need to make change. We need to write if else conditions, which is really very tough, because there can be hundreds of screens. So we can say the solution is create multiple localization files. Like here we have created string French fr.xml and strings.xml for English. Similarly, you can create multiple localization files. The key name or the name of the string needs to be same, only the value will be changed based on the locale, and the name of the string must be unique. This is the third most important. So let's see how it will work. So from profile screen, you will be calling let's say a data source, which is that static local data source, and static local data source will connect to respective static texts and load the information, return it to respective screens. So here we can see that profile screen, item listing screen, and cart checkout screen, all of them connected to static local. So all the changes, or we can say if we need to add more local, the changes will be on rightmost layer or at max middle layer, not on the left side. Now we found that profile unique name. Why unique name? In any applications, you will find there are lots of modules or lots of features. Let's say if we write something like search, then it doesn't tell that from which feature it belongs to. And let's say in multiple places we are using search, then it will be very difficult for us to understand or recognize. That's why we need to set up a naming convention for these string resources. For example, search text in product listing screen can be named something like this. It will be like module name underscore screen underscore id. So this search text in product listing can be named as product underscore listing underscore search is the name of the string that we can give. So this is we are saying that we need to set up naming convention, and also we need to create a check style or validator to prevent addition of any new string without proper naming conventions. Well, we have already told that what is the naming convention, but also we need to follow that. That's why the check style or the rules needs to be defined. So overall, if we see that this rightmost one is the resource validator check style, it works on top of this static test, where it will validate or it will check the listing names whether it has some prefix which was defined or not, or it's in proper it is following proper naming convention that we have finalized. So UI screen or from any point of or any screen from UI, the user, or we can say our application flow will be like, it will call to the static local data source, and static local data source will call the respective local or the text which needs to be loaded or displayed to the user. Now we can say in this case we are really were able to achieve this localization. So our application can go live, or we can say that let's say our application is in Play Store or App Store. Suddenly we found that one text is incorrect and we need to change it immediately when our application is live or users are using. How can we achieve this? as of now the content or the text is hard-coded, or we can say it is statically present in the client, or it is with the client. So if you need to make any change with the text, then you need to change in client code or client side that code, and then make a app release. So then what is the problem with the app release? We can release the app, no? All these mobile devices, they works on, we can say, real distributed system, and also it is the user driven, where we are saying that user can upgrade the app whenever they want. So if we make any change and publish the APK or IPA file, first of all the rollout will take some time, and let's say rollout happened 100% successfully. That doesn't mean that all the users will get immediately, because user needs to upgrade the application, which is we can say, which can be problematic in some situations. In those cases, how we can show the dynamic text, or how we can change the text? So the solution will be, or is like, remote content powered by server. That means this text needs to come from the server, and the client side needs to set the text dynamically or programmatically. In those cases, we can change any text at any point of time, because so server deployment is on our hand, and it's also, we can say, centralized place. So if we make any change or deploy, anyone who is making a call to that API services, they will get the latest information immediately. So in that case, it's like all this UI screen, they need to make a network call. Let's say that is remote data source, and that obviously the network call means it's a server, and after getting this localization data, it needs to be stored or for cache, and then it will be displayed, or it will be, we can say, delivered to the UI screen with the latest information. UI screen needs to update it. So now if we see overall, our flow became something like this, where we'll say that UI screen will call to a localization repository, where localization repository will take care of getting content from static data source or from remote data source. Here remote data source means from server. So we can say, let's say during app start, we can fetch the content and store it in some remote data source, and those texts are like localization text in here as described in the picture here. And so whenever this any screen needs some localized information, then first we need to check whether this data exists in my remote data source or not. If it exists, the data will be delivered from the remote data source. If it doesn't exist, then it will be delivered from static data source. In that case, we are also we have handled the fallback scenario, where if the content is not available with the server, then we are showing the static. But if the content is available with the server, that means it will be downloaded and it will be stored in client side in different data source, and that can also follow the similar strategy. So overall, if we see, the client logic becomes something like this. The left hand side is the client logic, and the right hand side is the server. So the client will make a network call to get the localized text, and the server needs to return that. Now just have a look on the server, where we have mentioned that there will be a web dashboard, database, cache. Now let's understand, we'll understand those things soon, why those things is what. Okay, now let's discuss what about server. So here server doesn't mean that it will have only one service which will return the JSON of localized test, but it should also give a dashboard where the organization's employee, or we can say some owners, can change some text at any point of time. We can consider something or simple like Google spreadsheet, where we can make any change to the text, and it can be also accessed, or it also it provides the APIs to get the response in JSON format as well. So something like that. So that means we need definitely we need a dashboard, and also we need the data in JSON format. And why this web dashboard? The major purpose of this dashboard is not the get call. In dashboard we can see the content or see the localization text, and we can make necessary changes or we can modify. So the major thing will be here as update. And whenever web or client hits this localization service, this location service will needs to update those things in database, and also use cache and update the cache. And in case of get call, first the localization service needs to retrieve the information from cache layer. If it doesn't exist, then it will try to get it from database and update the cache. And why cache here? Because making database call is really expensive every time. It may take some time, and we don't want to waste that time, or we can say keep the client or customer waiting. That's why the cache layer can be helpful. And this is, we can say, the memory cache. Okay, let's see in detail. First, let's understand the impact of the project here. What about the read operations? Read means the get localization text operation from server side. Let's say 1 million users are using your application every month. That means 33,000 call per day. What about write operations? We are using our web dashboard for writing. So we can say that as the only employees of the organization have access to it and update it, so write operation is very limited, while the read operation is more. What about the storage required? Let's say one screen contains 50 text to be displayed, and on an average, let's say that is 100 KB, and the application has 50 screens. That means and also let's say our application needs to support 20 languages. In this case, total storage will be required is 100 MB. Well, let's say the application also contains 100,000 items, and that needs to be also localized, like our product listings in generally e-commerce applications. Let's say one item text contains, or the description, name, pricing, all those things are there. So let's say it contains 5 KB. So, and also the same thing, we need to support 20 different languages. That means total storage required is 10 GB. Previously we found the storage will be required like 100 MB, but if we support the product informations, then it becomes 10 GB storage. So we found that this is really read heavy operation, and there is no relationship between the data, so NoSQL database can be used. Let's see the text tag requirement. Yeah, client SDK. For Android is Kotlin, iOS Swift, web JavaScript, but for API or a backend, here we can say additionally any server will work fine. Even Node server also will work fine, but Golang has, we can say, more benefits with respect to concurrencies. So we can choose any backend, and I prefer Golang here. And memory cache will be used. Let's say we have used Redis cache, and for the dashboard we can use React.js. And what is the API details? Let's say we have two types of API. One is get the data, another is update the data. Based on that, there will be multiple APIs, and the major components required for the scaling are DNS, load balancer, API gateway, memory cache, and database cluster. Those things we'll learn. We have learned about this in my previous video. Please go through that to get the detailed understanding. So let's say if we give static IP address, all these clients start to hit, and we need to scale the server. It will be problem because there can be DDoS attack or any attack, and this static IP can go down at any point of time. So there will be that means it needs another abstraction layer, or where we say that instead of static IP directly, the client needs to use the dynamic IP. That's why, or we can say it's more on readable name, where the user can, or where we need to write that xyz.com, and it will convert those things into static IP. That's where the DNS comes to the picture. And AWS Route 53 is one example of DNS. So DNS will resolve the dynamic IP into static IP. So it will take dynamic IP from the client and return the static IP associated with the server. So this is the overall DNS hierarchy, how it works. So now let's say we need to scale the server. So there previously we found that we were having one server. Now the connection requests are increased, so we need to increase the servers. In that case, if we give directly the server IP in DNS configuration, then it will be problematic. That means we need another abstraction layer, and that layer needs to take care of balancing the load between server, and if one server goes down, the load can be distributed. So those things need to be taken care. In that case, load balancer is used, and where we'll say the actual server is behind the load balancer. So DNS will have the contact point of load balancer. That means user is indirectly trying to hit the load balancer. Now API gateway, it is used in most of widely or we can say enterprise applications or Microsoft for microservices, where we were saying that different endpoints needs to be targeted or needs to be served by different servers. So in this particular server we may not need API gateway, but as we have already the servers, and our localization server will be part of that. In that case, the API gateway will be required, and these are the some key features of API gateway. And now the memory cache, why we need it? We found there are more read calls and less write calls, so frequency of change of information also is less, and also the call needs to be served or delivered very fast. That's why here we need the memory cache or Redis cache. So this is how the Redis or how this cache mechanism works with respect to the database and server. We have already discussed this in depth in my previous video. Please have a look on the previous video on system design for more details on this. So we can say memory cache is used to store frequently accessed data in memory so that applications can be responsive to the user with the capacity to designate how long you want to keep data and which data to evict first. Memory cache is actually not replacement of database. And as we found, the database is big, is 10 TB plus some extra, and that means also we need to scale the database. And in this case, ideally it's not that heavy also, we can say. So adding database and replica should solve this problem, and for further impression we can use shading, database shading. So overall, if we say the left side, we have already discussed that how the client design will be, and client will make call to the server, and this is the overall picture of how the server will have its cache and database. But with our current integration, it's like the client will call this DNS will map to the load balancer and then the API gateway, and again there will be load balancer for this different servers, and in case of our location server there will be load balancer as well for this location server, and location server will try to fetch information from memory cache, and location server will update the information in database cluster where we are saying the database, and the database replica will be there, and also it will update in memory cache. So this is the overall, we can say, the design of localization system, and it really helps to improvise the business of any product. For further any queries or for a feel free to drop a message or write in comment box. Thank you.